Here we are in Alibre Atom, and I've got a stool that is designed with injection molding in mind. So let's go through making something that has a little bit of a DFM flavor to it and show the capabilities of Alibre Atom in making things pretty easy. Let's start with a new part. And we'll head over to the XY plane, might as well, and start with the sketch. I'm going to start with a line. We'll go from here to here. Right, I'm making a simple outline of a step stool. From here I can grab an equal relation and go here to here is equal. And why don't I just assign this a dimension? Right, let's say I want this to be, I'm in inches right now. Maybe we'll say 12. We'll give an angle from here to here. We're going to say 87. Again. We'll grab parallel and make sure that these are parallel. We're getting there. Now we'll grab this and say not 60, but 6 rather. And then I'll have a height here. We'll go 9. And then what's not constrained here? I think I want this to be in the very middle with my degrees of freedom, and I can avoid another dimension that way. All right, so we're going to deactivate that. Let's do an extrude. Let's do the extrude again to about 9. We're going to go mid-plane on that. And then, if you can tell, what I've done for draft is to say that we're all drafting in one direction. Right, so that the mold tool will be able to release when these faces are drafted. So we got to do the same for these faces because these faces are vertical right now. So I'm going to grab my YZ plane, we'll activate a sketch, and of course I want to draft it down this way. I think I would like to do a little bit more than that. We'll make this vertical here. Actually, I'll grab a horizontal, and we'll make this horizontal here. Maybe I'll project that point with maintained association. We'll say vertical from there to there, right? So that point's fully locked down. And between the degree angle that I want to draft, maybe we'll go a bit more than we did before. We'll add another degree in there, right? Oh, I was thinking about 94 degrees. So we're going to say 4 degrees. And as I said, I want to add a little bit more to this. So what I'm going to do is actually take this line and make it for construction. I'm going to go from here, we're going to say tangent arc. There we go. Another tangent arc. And line. We'll say tangent. So I've added a nice little step on the side. All right, so let's add a vertical dimension, and that's just to keep the sketch just above our profile. We'll add a horizontal dimension. Maybe we'll make this, oh, looks like that's already defined. I guess because we're connected to that line there, so that'll work. We'll grab an equal, and we'll make sure that these arcs are equal. And then I want to define a line segment. So I'll grab a dimension here. I want to define the length of this to be 2.5. And the question is, what kind of dimensions are we looking at down here. So we're going to have less draft down here, but it will still be enough to get it out of the tool. Right? We'll go with, how about 2 degrees? And then we'll have kind of an abrupt transition, so smaller radius arcs. I'll define that by length. You're probably better off defining it by radius, though. 0.75, that looks about right to me. So we'll be using that profile a little bit later. And then how else can we define that? We give that 1 inch, we're fully constrained, right? So we're going to deactivate that. We'll do an extrude and a simple through all. We'll run a mirror. And we already have our extrusion pre-selected, so we'll make sure that we do it across the YX plane. And there we have part of the profile of our stool. So the next thing that we want to do is maybe cut out little legs on there. So on one side, how about on my XY plane, I'm going to draw a slot shape. We're going to go with line, line. We're going to grab tangent on all of these to make sure our slot is tangent. If I can click things sequentially. Horizontal. I'll go with the dimension. I'm going to give this a radius of something like 1.5. Right, we're making a real simple sketch here. And, whoops, I want to make that 5 actually. And then we'll go horizontal with this sketch origin here, and then we'll grab a symmetric constraint, and yep, we grab our line of symmetry, point, and point. Deactivate, extrude, through all. Now I could make a similar profile on the other one, but let's go back and edit our sketch real quick, and I'm going to say Control A on my keyboard and Control C. Let's try to simplify this process a little bit. Now I'm going to go to my YZ plane, activate my sketch, Control V, and there I was able to input my sketch pretty easily, and it kind of did the work for me. So maybe if I just click and drag this, right, however we're not defined, it looks like I'm just missing that symmetric relation. So we'll grab our line of symmetry. There it is. And then point and point. And we're fully defined. So we'll say extrude through all. And we're starting to look like a stool. The next part is kind of a big deal too. We'll grab fillets. And I'm going to actually, we're at half, I'm going to say 0.75. I'm getting all these sharp edges here. All right, great. We don't have to worry about any other edges because all this is going to be shelled eventually. Now, when it comes to stools, I think it's pretty handy to be able to have a little grip. Maybe let's do a hex pattern grip surface. So activate a sketch on the top here. And of course, I'll use my polygon. It's already set to 6. So let's apply that. And I want to, from point to point here, go with 0.5. Let's go with 4.25, maybe 4.5. That looks good. We'll go horizontal on one of these lines to orient it, and then we simply need a dimension up here, and I want to go off the edge a little bit. We're going to say, yeah, 3.125. Looks good. So we will deactivate that. And now I'm going to make another plane. And we're going to define this plane to be negative 0.025. And I'm going to click in here. Just, yeah, I've gone in the right direction, right? So now we're just below the face. If I use my handy view cube, you can see we're just below the face, 25 thou, enough to concentrate pressure on the areas in between the hexagon pattern, which I think we're looking for. So I'll highlight my plane, activate a sketch, and this time I think I have the luxury of just projecting a reference figure. And oops, let's try that again. There we go. We're going to maintain association, and then we're going to highlight everything, offset. Let's go with 0.175 and flip our direction. So now I've got a small hexagon inside a big hexagon, and if you're serious about this, then please fully constrain that, as that would be the best practice. For our video here, I think we're doing okay. So let's do a subtractive loft. And we'll go from here to here. And that's looking exactly how we want it, right? Now I want to make another sketch, again on this face. And again, I know a lot of Alibre users actually create a plane for every face that they sketch on because it can help you redefine sketch planes later. So keep that in mind if that would be a best practice for you. Let's go with polygon again, right? We're going to create our 6-sided polygon. And for design intent, how about I actually import this? We'll maintain association. We'll make that a reference line. And we can say parallel. And let's say equal from here to here. Now we'll go to dimension. And how far away do we want this to be? I'm going to go with 0.125. I'll add a line here. We're going to say perpendicular on this. All right, so our points are 90 degrees apart, and that sets us up well for a nice hex pattern. Next, I'm going to go back on plane 7 that I have defined over here, and we'll activate a 2D sketch. We'll again project, and I actually, why click all the lines when I can just click something like sketch 7. It's maintained association, and it's going to be a reference figure. And then I can hold shift, highlight everything. I'll hold shift and just unselect that point. And then we're going to say offset. And we'll flip direction. All right, so we just remade what we've already made. And then I'm going to convert that to reference. Again, fully constrain that if you're serious about any updates in the future. I'm pretty confident that I'm just going to make this video and not need to update it again. So I think I'm good there. Let's go with another cut loft. We'll go from sketch 7 to sketch 8, right? And then we've made another nice little hex pattern thing going on. So how do we propagate this? Well, we can go to our linear pattern, choose a linear path, say here. We'll choose these two lofts as our patterns. For spacing, we'll go something like 1.716. Let's change direction. There we go. That's a bit far though, so let's say 0.992. Yeah, see, that's a hexagon pattern there. And then we'll just tune up our instances. Looks like 7 is the magic number. And then our second linear path could be this edge. And our spacing will be 1.716. Oh. I'm going to turn up our instances here, and I think I need to change direction. That's it. So maybe one more. That's it. So we've got a nice hex pattern on the top, and we'll say OK to that. So we've done the top. Let's do this face, and we can talk about implementing that into our history tree, right? So in the sketch, we're going to do the same thing all over again. We've got our hexagon. Actually, let's import one line from the other hexagon. Maintain association and put it in as a reference. And we'll say have a parallel from one of these lines to our imported reference. We're going to say equal from the same. And that actually seems like it could probably be a good candidate to be horizontal. Then, if I drag this to kind of where I want it, that's kind of an upward section, so maybe just shy of that line. Say dimension and horizontal 0.99. I like that. Then deactivate the sketch, right? We need to create another plane based on this face. And we're going to say negative 0.025, just as we have done before. Yep, that looks like it's right. So we'll close and activate a sketch on plane 11. We'll project, and we'll just project sketch 9. Maintain association with references. There we are. Polygon. We'll apply and close and go horizontal. And then from here to here we are 0.175. So I guess I fully constrained that one. You can also just offset, which is nice. We'll deactivate the sketch. Activate a 2D sketch. Right, we're just doing this exactly as we've done before. We're going to apply that. Close. We're going to project there with maintain association as a reference. We're going to say OK, grab a line, go perpendicular there to there with the dimension length of our line to be 0.125. I know it's good to click 2 points, but sometimes you just want to click the line. We're going to say equal from here to here. And finally, how are we not fully constrained yet? Looks like we need to add a horizontal. So we're fully constrained there. And this will be the last one. We grab plane 11, activate a 2D sketch. We'll project a sketch. We'll do all of sketch 11 as a reference figure with maintained association. And then we have the nice luxury of selecting everything for an offset, except I'll hold shift and deselect some of these points. We will flip the direction and make sure that this circle is a reference figure. Close that. All right, let's do some more cuts, loft cuts. Nice to get through that tedious little section. And I selected the wrong profile there, so to sketch 9. Okay. Let's try that one more time. Lofted cut. We're going to go from sketch 9 to sketch 11. There we go. Lofted cut again from sketch 11 to sketch 12. There we are. So how can I implement this into this linear pattern that we've already done? Well, I can do 2 linear patterns, that's true. But I think it's a little bit easier to do something else. So we're going to take our feature pattern in the tree and drag it all the way to the bottom. Now I can edit my feature pattern. And why don't I add to my pattern the next lofts, since they're all the same size. And that's looking pretty good to me. I'm missing some patterns on this side, but I think for our purposes it'll be fine. I can always adjust this original sketch. In fact, let's do a little design intent test. I wasn't planning on doing this, but now I kind of want to. So let's grab, it was sketch 10, I believe. Nope, not sketch 10. Sketch 9. I did a horizontal relation, and that's what positioned that hexagon. Just doesn't look right if I don't go all the way over the boundary there. So if I move this up over here, .375 maybe. Let's go 3.5, right? So we deactivate the sketch, and of course, it actually updated well. This did not update well, right? Because I only made that. Yeah, I only made that one an offset without fully defining the sketch. And there's my daughter.
Where put this in the mouth?
Oh, Dad, here's my daughter. She wants me to put this flower toy in my mouth. There we go. And she's off again. All right, so you got to meet my daughter. That was a historic moment. Let's delete, 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 and delete. We'll go with polygon, right? So I like the way that that came out last time when it was defined. So anyway, that's the lesson in design intent and what happens when you're like me and you're making a video so you don't want to fully define the sketch. 0.175. And that way now everything updates just dandy. We can go even a little bit further on sketch 9. 3.6, right? And that way our pattern seems to be pretty fully in there. We'll generate the last feature now. Good, and since we have a wider base, you can see we're missing a few hexagons on that side, and that of course is an easy fix. We're just going to go from, what, 7 or 8 to 1 more. And there it is, right? So now we're looking complete on that. So we're going to want to do a shell. And this is where we determine the wall thickness. And the wall thickness is going to be very important because it drives so much of the support features of like hole dimensions, of rib sizes. I mean, it just determines everything. So let's grab a shell. We'll grab this face. This face. You know what? This is making Alibre think a lot. It can do the shell, but as you can tell, we have to think a lot when we select our faces. So I'm just going to cancel that. Instead, I'm going to hold Shift and select all these faces already. And that way I'm not running the same computation over and over as I select these faces. So now we'll shell this out with our faces selected. We are set to a shell thickness of 0.2, and I really like 0.2, so let's leave that. Say OK. And we're shelled out hollow. Finally, and this is kind of a big deal, I want to make sure that we're good on rib patterns, because when you injection mold, you get a lot of ribs, and patterning those might be a challenge with the kind of design intent that we're looking at. So let's do a precise section on this plane. Yeah, I think that way. Good. We'll close. We'll start a sketch on this plane here. And of course, in the sketch environment, I'm going to reset my view. Let's go to this very edge here and sketch out a line. Now, when it comes to injection molding, rib widths and heights matter. And they can mean the difference between success and failure. But also, injection molders will break the rules all the time. So these are the rules, but it's kind of a suggestion that your rib height is going to be 2.5 times your wall thickness. So our wall thickness of 0.2, we'll multiply that by 2.5. So 0.2 times 2.5, and then we have to have a draft angle, right? That's how you get the part out of the injection mold machine. So I'm going to say 4 degrees on that. We'll see if won't quite let us move it. Yeah, we should add some more dimensions. We'll grab the origin there, and we're going to say, how about maybe 0.5? Yeah, I think that looks good. So there's our 4-degree angle, and I want to make sure that both sides are kind of pointing inwards. I'll hold Shift and make these equal. And then, so these are just the dimensions that we care about. So 4.35, I'm doing a little bit of overlap to make sure that we're going to stay inside this model as we go through a surface that isn't even. And that does give us a little bit of wiggle room in adding our rib features. We can make that a little bit taller if we want. Other than that, how are we not constrained? We just got to do the width. Now, rib width you define from the base, and you would have fillets down here. I'm kind of omitting those for now. But your rib width is really dependent on your material. Yeah, there's my rib angle. So if you're working with an amorphous material, amorphous is going to be your wall thickness, all right, 0.2, and the maximum allowable width for the general rules of thumb is going to be times 0.5, right? So amorphous materials is your wall thickness halved is the maximum thickness of your rib. If you're working with a semi-crystalline material, you can go your wall thickness times 0.75 or 75% of your wall thickness. So we've got this rib profile hammered out. That looks pretty good, right? We deactivate the sketch. And now this is pretty easy, right? Because we extrude. Let's reverse the direction. But we don't want our rib to come all the way past this wall. We want our rib to meet this inside wall and know to be done when it's met this inside wall. So we're going to say to next. And now that we've thought about that, we do not protrude outside our wall. We just go to next and stop, right? It's a wonderful piece of design intent. All right, next we'll go to linear pattern. We'll choose our path, something like right here, and we'll do a features to pattern. Great, so we have this rib that's getting patterned. Make sure that you have one instance over here. If you don't, we'll go to change direction. I like the spacing of 0.992 because it's kind of consistent with that honeycomb pattern. We're going to say maybe 7. Let's see where 7 puts us. Well, 7 makes something impossible. 6. 5. 'There we go. So 5 looks like a pretty good rib pattern to me. We're going to say OK to that. Now let's do, how about a mirror, right? So if I take my precise section view and I exit that view, we'll want to do a mirror on this. That would be over here. And for features, we want to do our extrusion and our linear pattern. There we go. And our plane will be our center plane, of course. And those are our ribs. Next, let's go with this plane. And we're going to create a plane referencing off of that. And we're getting pretty close. Let's say negative 0.55. Yeah, we're kind of on the far end of that rib. I like that. So negative 0.55. Close that. Highlight our plane. Activate a sketch. Now, of course, I can't see anything that's meaningful, so we'll go to Inspect, Precise Section, rather. And it looks like plane 18 is pre-selected. We'll reverse our view. And close, right? So now I'm looking at the rib, which I think is a little bit more useful. And under view, I want to go with wireframe. And that way I can see right where the bottom is here and where the top rib is here. So we're going to go back to model, or I guess I should say, oh yeah, model. And then I'm sketching on this plane, right? So we'll create a sketch. Now we want to make more or less the same rib. So I've already established my rib height on the other side. So that's worked out well for me. So yeah, you can tell my rib height is going to be that guy. So we're going to say coincident. This point. Yep, right there. Same draft. Actually, this is a good opportunity to say equal, so we're going to make sure that these guys are equal. Dimension to 4 degrees. And then I can give this whatever height I'd like because I'm already constrained to the other rib's height, so I just have to be in the middle, so I avoid that uneven surface. And we'll say something like 0.6. And now our rib width, I think we did 0.5, so 0.2 times 0.5. And then I think I've got 1 or 2 other dimensions to go. Yep, just that one. So come over here. .5, so we're going to deactivate the sketch. Next, let's go to View, go back to Shaded and Visible Edges. You might be starting to think about a problem that we're going to have. That's going to be, I have my sketch right here. Not that sketch actually, but my sketch 14. Look, I did my sketch wrong. This rib is taller. That's going to totally ruin what I was trying to say. So we're going to edit sketch 14 and get that fixed. Of course, that's what I get for going into that view. So we've got to get rid of a coincident on there. I guess this is a reasonable example of editing a sketch. Hopefully someone watching might need that. So where is my coincident? I'll just delete my imported line. Yeah. We're going to say coincident from this point onto that edge. That's better. Okay, now it's making the point that I want it to make. I made these ribs using up to next. And now that I'm doing a rib this way, if I try to extrude this rib up to next, like I did last time, so that it will end nicely on the wall. Looks like we're just working on our face. It meshes down here. I'm going to say to next. And I need to reverse my direction so that it goes in the way that I want it to. Still working on those face meshes. It doesn't even give us anything valid because we're already in a solid, right? So how do we establish the design intent to go over here? Now, sometimes you can be successful if you say to geometry. And then we can select a geometry like this back wall. But you can see that we poke out the other side because we are going straight to that face. So to geometry can sometimes have problems. This curvy face probably isn't an ideal solution either. Could be. But why don't I do something different? We're going to cancel this extrusion entirely. We're going to do an extrude cut. I can drag this, say, just past the last rib. Yeah, that's about perfect. Our graphics are still updating here. And there we have it. So, what does that buy us? Well, after I select this and we work on our graphics, that's better. I'll grab my plane again. Activate a 2D sketch. And then from here, I can take my sketch 14, import it with maintain figure type, maintain association. And now I can deactivate my sketch. And when I go to extrude this, I have a clear path all the way to my back face. And since I used that same sketch to cut everything out, I just fill back in what I cut out. So I can maintain my design intent with one simple cut. So we're going to say extrude. We'll reverse and say to next. Almost done calculating the graphics, I think. And OK. So you say, that's great, but can you pattern it? And you sure can. Let's turn off our precise section. And let's go with linear pattern. And I'll choose my cut and my extrusion. Linear path. We can choose an axis if we wish. There's our pattern so far. Let's try something like 8. There it is. So that is how we would linear pattern ribs, but that isn't the only option to linear pattern ribs. So sometimes if you get in a bind, that's the best option. But let me go over a different method to linear pattern ribs as we do the ribs down here. For that, I think I'll need another plane. We'll just go in the middle somewhere and apply that. Alright, so we'll start on our plane here. I think I have a precise section for that. So add a precise section there. And we'll give this plane a sketch. We'll reset our view. Right, we want to do some ribs up here. Again, same thing. We're going to have the same rib pattern. Again, a lot of injection molders will break the rule and go a lot longer on the ribs. There are risks associated with that. You can get sink up here, where there's so much material down here that as the plastic cools, it shrinks and it sinks this top surface that the rib is under. That is a distinct possibility. You also can get short shot, where if you try to run plastic so long and so thin, it may not fill the cavity all the way, and it dries out before it's full, and then you just don't have a complete injection mold like you've intended. So that could be a problem. So we're going to say 0.2 times 2.5. And then I guess I'll see if, I'll just dimension it relative to the origin. Again, depends on your design intent. So 8.86. Rib width, I think we're doing 0.5, so we're going to say 0.1 there. We're going to make sure that these are equal. Already exists, very good. We'll grab a dimension from there to there to make an angle. We're going to go back to our standard 4 degrees. And I think the only thing we have left to do, is figure out where we want that. I'm pretty flexible. Let's say 1.25. We'll deactivate that. And again, you can make the ribs a bit longer if you want, because we are having our sketch be partially inside due to the uneven surface. Let's do an extrude. And we're going to the right side. So what we have to do is, after this is thinking about the graphics, establish our design intent to go up to next. All right. Next, let's grab our linear pattern, right? We're rebuilding our pattern from here down to here as well. So features, we have this extrusion. Our linear path will be something like the direction of that edge. And then it doesn't like our number of features, so I'm going to take this down to 4 and see how that is. Again, I like the 0.992 because it's so consistent with our other pattern. So there our graphics are calculated. I think that's going to be a fine pattern for what we're going for. I'll just try 5 to see what happens, but I think 4 is pretty good. Yeah, doesn't really register with 5. So we're going back down to 4, and we'll accept that. So we've got these ribs made. And the next thing is, how do we deal with ribs crossing that isn't what we've just already done? So I'm going to grab this top face. We're going to go with a plane. We're going to say 0.001, right, 1 thou higher, and apply that. So with this difference, right, you can do little tricks to where even you can do the method that we did last time and just have one rib be a 10,000th of an inch higher than the other one, which is insignificant for tolerances, but which the CAD system can still pull that up to next geometry. So we can just change the rib height slightly like we did last time, or like what we could do last time. Or I'm making a plane here that, as you can tell, just has this tiniest gap above the rib. And we'll close that, right? So I'm going to grab my plane, create a sketch. Here's another way of doing it in case, I don't know, you have some more fancy design intent, like a more intense uneven surface or something. I'm going to draw my rectangle and just go past both ribs. And we're going to take this dimension, right? 3.5 looks good. We'll project here and here. Reference figures, maintained association. And that gives me the luxury of taking my line, just drawing a construction line from point to point, and we're going to say equal. Oh, I did not want to do that though. Equal from, yes, thank you, equal from there to there. And that way I've captured the correct rib dimensions to be consistent with the other ribs. And as you can tell, if I have a really fancy surface down here, I can come down and extrude to surface. We're going to call this defined enough. Again, you've already seen the consequences of not fully defining a sketch, so this is kind of the same risk that I'm taking here in design intent. It's not best practice. It's just best practice for time, I guess. And now as I go to extrude that, look how much faster we are rebuilding. I'm going to do a reverse and then up to next. And that's looking good. So the question is, why did I create a plane and go 1,000th above? Well, if I choose this face, activate a sketch, and I create a cross rib going right across it, deactivate my sketch here. So my cross rib is the exact same height as the other one, like it is in the other one. We're going to go to extrude. Again, I'm enjoying these faster rebuilds. We're going to go to reverse, to next. And for some reason, the to next intent breaks the rib up in between sections. Not sure why that happens, because if I go to depth, then that doesn't seem to happen at all. So not sure why that is, but that's just a simple way around it. And you think the tolerance of that, you can make that a 10,000th or 100,000th, right? You can do a lot of decimal places. And you can even, if I add one more zero here, and then generate to last feature, you can tell we're an order of 10 times smaller than we were before. That's never going to show up in tolerances. So that's a, legitimate way of doing it. So, and again, it looks like it's oversimplified because this is now like a planar surface, but we had that hexagon pattern before. So if you have a really intense pattern that you got to put a rib on, which happens, then this is a pretty good method for doing it. And this other method that I used to create these ribs wouldn't work for that, right? So this is a way that we can be a little bit more intense about it. So if I sketch on this face, I like the grid there because I can make my sketch plane out pretty well as my view changes. We'll grab this face, maybe we'll project a sketch, right, with maintain association as a sketch figure. And we'll deactivate the sketch. We're going to extrude. We're going to go up to next. And that's how we can define and have our up to next geometry over here, right? So we have options when we talk about these ribs and rough surfaces. Highlight this face, activate a sketch. Come over. It's kind of odd how my sketch plane is acting. Project to sketch. I'm just going to project the last sketch actually. Sketch 19, maintain association. That works. For some reason I was having a hard time converting that face. I'm going to say deactivate sketch. I'm going to extrude up to next. And we're going to say, okay, now with the correct design intent, we should be able to bring back that hexagon pattern and not have any problems. So let's give it a try. We're going to unsuppress our hexagon pattern. And this is going to take longer rebuild times, of course. Yeah, everything looks fine and nothing in the tree broke. So that's another part of design intent, making sure that things don't break. Next, how about I run a linear pattern and I pattern this extrusion. I'll choose a linear path this way. And I might need to change direction. That could be the holdup. Great. So I'm going to take that to 7. We'll take off this section here. And then all I have left for me to do is mirror those ribs should be right there. And my feature pattern, select that. We'll choose mirror. We'll choose mirror plane. Again, generating graphics. Now notice our design intent made us go up to next, which was this rib, and that's fine because we can take our mirror and move it down below our feature pattern and the other extrusions. And when I let go, we should have the design intent to go all the way up to next. There we go. So as you can tell, it's really valuable to be able to reorder things in the history tree on command. Next, my feature pattern, I'm missing a few features. So in addition to what we've already got, and I think we're regenerating our graphics again. There we go. I want to add in extrusion 28, I believe. And also extrusion 27. So that should be our stool. There's a few other parts of injection molding that might be worth going into, though. There is something interesting known as cut with draft. And it's actually really interesting and applicable here. So we're going to activate our sketch, and we're going to do so on our base plane, right? The plane that the stool would be sitting on. And we're going to look at it from underneath. And let's import a few references. We're going to project this line, right, where we start to curve abruptly on the inside. And this line, we're going to make sure that they're reference figures with maintained association. And now as we reset our view, we have these nice references to where we curve abruptly. Let's make a rectangle about that big. That's something like 2.25. Well, 4.25. Let's deactivate that sketch now. Right, so we're taking advantage of the fact that we have a slanted face, and we can cut straight up. Again, these rebuild times are catching up with me, so I'll have to resuppress a few components. All right, let's say okay to that. And just see where we're at, because I think we have a few things to adjust. But yep, so there we are, cutting with draft. You can tell we went straight up and down, but because the face is curved, we were able to make a cut through there, and also our tooling can go straight up and down at that point, and we can just cut away the draft like that. So let's do a quick adjustment, but first let's suppress a few feature patterns that are going to be a little bit recomputationally heavy. So we've suppressed that. We're going to suppress the big pattern. And suppress the big pattern again. Alright. So our ribs ought to be good. Our plane 25 broke, but we'll just unsuppress that, and that will fix that plane. Now I can edit these sketches a little bit faster, right? So we're going to edit this. And I need to extend this a little bit past my face. So why don't I just delete that sketch? In fact, does that make it? Yeah, that makes it so I can extend it past pretty easy. I'm going to make sure that these are equal. We'll add a dimension about 0.75 because we can afford to go pretty deep on that cut. We'll deactivate the sketch. All right, so that's a cut with draft because our tooling can, again, go straight up into that and just be able to cut that face open. So I think that's pretty useful and pretty cool. But maybe we'll want to have a little bit more purchase with our fingers when we grab this little handle to pick the stool up. So let's work on that. I want to actually sketch on the face that I'm cutting with. We'll activate a 2D sketch and reset the view. Actually, you know what? Before I make this sketch, I'll add a little detail. We'll add a fillet here and here. And we'll say something more like 0.5. And apply that. I like that. You know, my handle really isn't that centered. So, again, the beauty of parametric CAD modeling is we can go to our extruded cut, edit the sketch, 1.75 maybe, and 4.35. It's still not a huge handle, but it shouldn't be a heavy stool, so come down there. That's still, I like that better. So now, highlight this face, activate 2D sketch, and we'll reset the view. We'll project all these different line segments, but actually I just want the segments, not the face, so we'll remove that. We're going to maintain association, highlight everything. We'll go with an offset. How about 0.2? And if you're serious about all this, make sure that this gets fully constrained for the reasons that I'd mentioned before. Deactivate the sketch. Yeah, that should be good. We'll go with extrude. And again, I have the luxury of saying to geometry right there. All right, so I get a little bit more purchase on my handle when I pull my hand out, and that should still be completely compatible with all of our injection molding tools. So we can get them all to work out really nicely. Let's do a mirror. And I can mirror my cut here. Maybe I can mirror a fillet, and I can do an extrusion. I can do so across this plane. And everything works. I'm glad when fillets work when they mirror. That's pretty cool. All right. Feet. Maybe I want to add some feet. I'll activate a sketch here, right? This should be just a super simple sketch. We'll project a few sketch entities. Maintain association, and as sketch figures, we'll say OK to that. And I can make an arc. We'll do a line over here, line, and line. 0.2, we'll go horizontal. And we'll make sure that we have a tangent relation between these. And we're fully defined. We can do the same thing over here, and we can do it all in one. Project. You can also use offset sketch if you're feeling daring. maintain association, arc, line, and line, one more line, horizontal, and horizontal. We'll go 0.2. And it looks like we need a tangent, and I think we'll be fully constrained. We'll deactivate the sketch. We'll extrude 0.2. And there we have kind of a relatively consistent thickness there. Feel free to add fillets because that would be important. You know, sharp edges and injection molding isn't really that great. We'll go with mirror, and we'll mirror our extrusion across this plane. So we're rebuilding pretty good. Our last step, let's unsuppress all of our patterns. If I was smart, I would have unsuppressed that one last. Yep, so I can select multiple things at the same time and unsuppress that. Is that our last suppressed pattern? I think it is. So that, my friends, is an injection molded stool design. So, hope this was helpful. If it was, please subscribe. I'll see you in the next one.